Okay, welcome to Applied Materials and Corrosion. We want to measure the voltage at a carbon electrode here. I just showed you the case of it. Here it is, the carbon electrode. Just the end is exposed to the solution. We're going to put the carbon electrode into the solution and measure its voltage compared to a reference electrode. The reference is silver with silver chloride on the surface, and it will react, so it will either turn into more silver chloride or the silver chloride will turn back into silver, which gives us our reference measurement. We're going to then use that in an iron 3, iron 2 coupled solution. We're first of all going to add iron 3 sulfate, measure the voltage, and then add iron 2 sulfate, and then we're going to add a complexing agent. So first of all, the iron 3 is being added. By the way, this is all at slightly faster than normal speed, because it takes a long time in the lab. So here I am going to add some water to it to get it all wet. It will go up to 500 millivolts, which is on the scale. The scale is the most sensitive scale of this multimeter, which is a millivolt scale. So now it's in. We can see it says 50 something. It's actually 55, so 552 millivolts, or 0.55 volts. Is the difference between those two electrodes. Now I'm going to add some iron 2 to the solution, which will change the redox potential of the solution, because we've got a couple iron 3, iron 2. That will reduce it down to 400 and something. I think it's about 413 when it finally settles down. Obviously it's got to mix around and it's got to equilibrate. Now we've got a fixed redox potential caused by the solution. So here we're fixing the redox potential using the solution and not using a power supply. We could use a power supply to vary the redox potential. That's the other way to do it. Now we add the complexing agent. It will make a colored complex of iron salicylate, which is one of the two oxidation states, is very, very soluble. It doesn't seem to have a very large effect on the voltage here. Not entirely sure why that is. It can have a large effect on the voltage. It doesn't have a large effect on the voltage using this carbon electrode. It's still recording. What we can see is that the color is incredibly deep. We had a very light sort of urine-y color beforehand, and now we've got nearly black. It's deep purple, really. The color of the complex is caused by charge transfer between the salicylate ion and the iron in the center, and it makes a very large effective orbital which absorbs a lot of energy, and the iron electrons can jump up and down. Some of them can get onto the onto the ligand. What we can see here, however, is that the voltage measured between the two electrodes is not different when we added the salicylate, but it was different when we changed the composition of the solution. Next time we will try to do this using an iron electrode, which adds another component to the possibilities. We might only add one of the two iron salts in that case, because otherwise we have too many things going on. Obviously with the carbon as an electrode, it makes sense to add two salts so that we've got a redox couple in there. We'll try this again next time when I get back into the lab.